Uh, Hello everyone, my name is Sandeep Kumar and I belong to EEE236. Here I am giving the presentation on topic 3D real sense technology as a part of my final presentation submission. So today we will discuss in detail the 3D real sense technology. It is outlined as per following. Firstly, we will cover introduction, then we would go on 3D tri-gate transistor, then after that we will cover SDK, and after that we will go through applications of 3D real sense technology, and in the end we will discuss about conclusion. Let's go to the introduction part. The personal computer is decades old, but in all the time, how personal has it really become? Do you interact with your computer the same way you interact with your friends or family? Does it understand your communication style? Real sense technology recognizes and understands input using your hands, face, and speech as well as from the environment around you. We have been talking about Intel's RealSense 3D depth sensing technology for years, but the technology actually came up in the market in 2015 with more than half a dozen PCs and tablets from the likes of Acer, Dell, Lenovo, and HP now shipping with the technology and more devices to come. It is really important for us to know how really it works and affects our routine life. We can implement this technology by using real sense cameras. Let's go to depth sensing technology, what it is actually about. Real sense cameras features three lenses, a standard 2D camera for regular photo and video, along with an infrared camera and an infrared laser projector. The infrared parts allow real sense to see the distance between objects, separating objects background layers behind them and allowing for much better object facial and gesture recognition than a traditional camera. The devices come in three flavors: front facing, rear facing, and snapshot. Now let's have a look on 3D tri-gate transistor. The base part of real sense 3D technology covers 3D tri-gate transistors. So basically 3D tri-gate transistors form conducting channels on three sides of a vertical fin structure providing fully depleted operation. Here are the advantages of using 3D tri-gate transistors in real sense technology. Tri-gate transistors can have multiple fins connected together to increase total drive strength for higher performance. Its dramatic performance gain at low operating voltage. 37% performance increase at low voltage, greater than 50% power reduction at constant performance. Improved switching characteristics, high drive current for a given transistor footprint, and only 2 to 3% additional cost. Let's talk about SDK. SDK means software development kit. We can also refer SDK as device kit. It is typically a set of software development tools that allows the creation of applications for a certain software package, software framework, hardware platform, computer system, video game console, operating system, or similar development platform. To create great applications that take full advantage of real sense technologies and the amazing real sense 3D camera, you need to download the real sense SDK from Windows. The Intel RealSense SDK for Windows Beta is an API and tool supporting 4th generation and future Intel Core processors. It is available now as a free download. And for SDK architecture, it's composed of application RealSense SDK package that consists of libraries, developer tools, and also SDK runtime that composed of core, hand tracking, speech, face analytics, background segmentation, depth camera management that is composed of power management, input output module, and also USB video class camera driver. It's also having camera module and camera firmware. So these are all the components of SDK architecture. Let's talk about applications of 3D real sense technology. As we all know, 3D real sense technology is an emerging technology and it's having a lot of applications in day-to-day life. Its applications are listed realistic avatars, 3D scanning for 3D printouts, green screening without a screen, photo layer editing and focusing, measuring distances in pictures, 3D gaming with Oculus, object avoidance, accurate gesture control, and holographic navigation, and few more. Let's discuss each one of application one by one. Let's talk about the first application of 3D RealSense, that is realistic avatars. RealSense is really good at scanning faces and turning them into objects that can be used not only in 3D printing but also in software. Face Shift is such an application that replaces your real face with an avatar for video chats. Apart from that, the only disadvantage it has is that it would not be able to stick out the tongue when the user does, because it can't detect the inside of one's mouth. Let's discuss more on Face Shift application and how the application actually works. In Face Shift application, after leaning in for a few seconds so that the software could scan one's face, the user would be able to chat as a robot, a red-haired boy, or an ogre. If the user moves his eyebrows, lips, and cheek muscles, the avatar would follow his expressions closely. There is one more application based on the same, which is called 3D Me. It scans your face, puts it on a digital body, which can be printed as a figurine. However, if that avatar could be used in games or virtual worlds, it could be even more compelling than a chat ogre. Let's move forward to the other application of RealSense, that is 3D scanning for 3D printouts. Though you won't be able to buy a system with a rear-facing RealSense camera until later in the year, Intel has a prototype tablet that can scan people's torsos and then 3D print them as decorative crystal paperweights. The potential is there to create not just interesting paperweights but fully functional 3D printed objects. Just imagine 3D scanning one screw in so you can print out another one. Front-facing RealSense cameras can perform 3D scanning when used with the right software. Of course, the ergonomics of pointing your laptop webcam at an object presents a challenge. To maintain the spirit of technology, we got to do that, and in order to maintain that, you had to lower the lid to just the right angle so you can get a small object in front of the deck and then carefully rotate it or use a rotating platform to capture all slides. Let's discuss one more important application of 3D RealSense technology, that is green screening without a screen. If you are doing a video chat and want someone to see your face, but not the messy living room behind you, a program called Personify will automatically remove the background and replace it with a graphic or a plain white space. In the past, you needed to film against a solid color background to separate your torso from the objects behind you. But RealSense depth sensors can tell the difference on its own. Imagine doing a podcast about outer space with animated stars behind you instead of your basement paneling. Picture yourself doing a video call from home with your boss and showing a blank white space behind you, rather than the wall your toddler just scribbled on. Let's discuss about photo layer editing and focusing. RealSense cameras allows you to change which layers of a photo are in focus long after you capture the image. You can even use filters that transforms the color of some layers while leaving others untouched. When the user opens a photo of a vegetable stand and selects refocus from the editing menu, he would be able to blur or sharpen each set of vegetables just by tapping on them. Let's move forward to the other application of RealSense, that is measuring distances in pictures. The Dell Venue 8 7000 tablet has a RealSense snapshot camera which adds depth information to photos it takes. With photos taken on the tablet, the user would be able to measure the distance between 2 points by drawing a line on the picture with their finger. For example, the software would inform the user that the radius of a bike wheel in a photo was 27 inches. It has certain limitations to it. It can't calculate everything. If the user would try drawing measurement lines on a photo of an ice cream stand, the software would inform the user that many of his lines represented distance that were too far to measure. Let's discuss one more application of 3D RealSense, that is 3D gaming with Oculus. RealSense can add hard recognition to existing game systems such as the Oculus Rift VR glasses. While Oculus has always provided the ability to play games in an immersive virtual world, it normally requires a controller. Adding depth sensing cameras allows users to use their hands as a controller. This is a really very important application of 3D RealSense. Let's discuss about the application of 3D RealSense named object avoidance. How do you make sure your new drone does not run into someone else's drone when you take it for a flight in the park? Using the drone with real senses cameras on each side, allowing it to see how far it is from other objects, and thus it can avoid a collision. Imagine using the same technology in a self-driving car or to assist you when you are parallel parking your own vehicle. So this application is really helpful in avoiding a collision in day-to-day life. Let's discuss some other applications of 3D RealSense technology. Those are accurate gesture control and holographic navigation. Let's discuss about accurate gesture control. You can do gesture control with a regular 2D camera, but it does not always work well, particularly if your hands blends into the background or you put one hand in front of another. RealSense can easily distinguish all your fingers from each other and from your body and the world behind you. So that's why you can do accurately gesture control. And the other one is holographic navigation. Intel has shown a prototype PC with a virtual navigation bar that appeared to float on air in front of the lower screen bezel. RealSense did not create the holograph itself, but it allows us to interact with the virtual buttons by judging whether our fingers are at the right height to tap them. Finally, what I concluded from this presentation is that RealSense technology is the future of all applications. The way it provides easiness to the user, it's definitely worth using, and it is really user friendly and it's also very environmental friendly. As we discussed, it has many real-time based applications. So finally, coming to the end, I personally feel that this is the future of 3D RealSense technology, and it seems quite useful to the mankind, and hence I emphasize on using this technology. I really thank you all for watching my presentation. Your reviews are most welcome, and I really look forward to hear from you guys.